In this video, we are discussing a very serious topic, that is the selection of value of k. We know that in case of KNN algorithm, k denotes the number of neighbors we are considering, and we always try to take the value of k as odd so that there should not be any tie and there is no need to go for any tiebreaker also. So what should be the optimum value for k for which my model will be more predictive? In case of k nearest neighbor, that is a KNN, is one of the simplest supervised machine learning algorithm mostly used for classification, and it classes a data point based on how its neighbors are classified. So here in this particular diagram, you can find that following are the different boundaries separating the two classes with the different values for k. So for k is equal to 1, we are having two classes, one with the denoted by the red dots and another denoted by these blue dots. You can find that here we are having the respective boundaries. For k is equal to 3, for k is equal to 5, for k is equal to 7, you can easily find that how this boundary is being changed and how the boundary is getting more and more smooth. And in case of KNN, it classifies a data point based on how its neighbors are classified, and the areas and the respective the class of unknown data point are different at k is equal to 3 but can be changed for k is equal to 7 also. Here you can find that here there are some points which were there in this particular class for k is equal to 1, but here these points are having no touch with this particular area. So that means you can find that there is a class of unknown data points are different at k is equal to 3 but also can change at k is equal to 7. So which k we should choose? So that is a big question here. So if you watch carefully, you can see that the boundary becomes smoother with the increasing value of k, and with k increasing to infinity, it finally becomes all blue or all red depending on the total majority, depending upon the voting. So KNN algorithm is based on feature similarity. So choosing the right value of k is a process called parameter tuning. So the selection of the k value for this KNN algorithm, or say for a nearest neighbor algorithm, so here this is known as the parameter tuning and is important for better accuracy. Although the best way to choose the value of k are, so here we are suggesting that how to select the value of k in a better way. So either the higher the value of k has the lesser chance of the error, but there are other traditional methods also like k-fold cross validation. In abbreviated form we can call it as KFCF. So there is a k-fold cross validation and to decide the value of optimum value for k, and you can use this k-fold cross validation for testing performance of KNN with some various quantities of neighbors, and it will be useful in that case. Just consider this respective graph. Here we have plotted the value of k along the x-axis. You can find that we have started from 0 and we have proceeded up to a large value for k, and here we are plotting the error. So you see, when the value of k is equal to 1, then we are finding that the error is 0, because you know that error rate at k is equal to 1 is always 0 for training sample, because in this case the closest point to any training data point is itself. So hence the prediction is always accurate with k is equal to 1. But you see, when the value of k is increasing, also there is a probability that we are finding that there is a quite rise in the value of the error. So now let us go for another graph for the better understanding. So following is the curve for the training error rate with varying value of k. So at k is equal to 1, we are overfitting the boundaries, and you can find that for k is equal to 1, the validation error is highest in that case. You can find that because the overfitting is taking place, because the model may work good in case of say training data set, but it will be having a very poor performance in the test data set. So hence error rate initially decreases and reaches a minima, and then after it increases with the increasing value of k. To get the optimum value for k, you can segregate the training and the validation from the initial data set. Now plot the validation error curve to get the optimum value for k. So here you can find that here at this particular bottom, I'm finding that for a certain value for k, I'm getting this validation error with the minimum, and this value of k should be used for all predictions in that respective model. So let us go for one practical demonstration that how this optimum value for k can be calculated. Here we are having one sample Python code to find out the optimum or the best value for k for which my model performance will be best. So identifying the best value for k. So at first we are going to load all the required libraries. We're just going for from sklearn.neighbors import k neighbors classifier. From sklearn import datasets, and from that particular datasets will be dealing with the Irish dataset which is already there in our sklearn datasets. And from sklearn.preprocessing import standard scaler for the scaling of our data to reduce the computational complexity and challenges. And from sklearn.pipeline import pipeline, and from sklearn.model selection import grid search CV. So these are the libraries we required in our sample code. So load Irish flower data, and load data will be done from the datasets. So that is datasets.load Irish. So we are calling this method and it is returning this Irish. Now what is this Irish? Irish is nothing but one dictionary. So now it is having so many keys. So one key is our data, another one is our target. So we are keeping this data into this capital X and target into this small y. We know that in case of Irish dataset we are having 4 feature variables, and those 4 feature variables are sepal length, sepal width, petal length and petal width, and we are having 3 species as output. So that they are Setosa, versicolor and virginica. So we are having 50 rows for Setosa, 50 rows for versicolor, 50 rows for virginica. So if we print the value of x, you can find that as we are having 4 feature variables, so we can find that we are having this array of arrays. So we are having these 4 values within this one array, and in this way we are getting this 150 number of arrays in another array. So now this is my y. You can find that this is another array, and here we are having this 50 number of zeros and 50 number of ones, and then 50 number of twos are there. So in total 150 number of elements are there in this respective array. So 0, 1, 2, so they will be going for denoting the Setosa, versicolor and virginica. So here we are going for the standard scaler. Now what is the standard scaler actually? So here we are using the standard scaler which subtracts the mean from each features and then scale to unit variance. So that is the purpose of the this particular standard scaler. So standard scaler object we are forming here. So here we are calling the respective the method standard scaler method. So it is creating one standard scaler object. So the name I have given here as standardizer. So this standardizer dot fit transform x. So now we are getting this x standardized, and if we go on printing them, we are finding that these values have got standardized. So how it has got calculated? By just subtracting the mean from each features, and then it has been scaled to unit variance. So here we are getting these respective values. So you can find that. So these are the respective values we are getting. So now fit a k nearest neighbor classifier. So fit a KNN classifier with 5 neighbors. So for that particular purpose, here we are going for this k neighbors classifier, and then k neighbors classifiers, and then we are passing parameters as n underscore neighbors is equal to 5. That means here we are putting the value of k is equal to 5, metric is equal to Euclidean. So here we are going for the distance metric, or the distance function is Euclidean. We can also go for the respective Manhattan distance. We can go for, say, we are going for, say, cosine distance and so on. So there are so many distance metrics are there. We have discussed all this distance metrics in our earlier videos. And then n jobs is equal to -1 dot fit. We are passing this x and y. So x standard and y there. So in this way, we are just defining the classifier object, along with we are calling the fit method. This fit method, we know that always it will be used for the training of our model. So KNN is the K neighbors classifier class object. So the number of parallel jobs to run for neighbor search, and if we put that is the n jobs is equal to -1, then it means that the number of jobs is to set to the number of CPU cores available. So next we are going for this pipeline. So create a search space of possible values of k and create a pipeline. So here is a pipeline class, and this pipeline method we are calling it, and you know that it is creating one pipeline object. So pipeline is the name of the class, and here we are passing the two steps are there. So one is the standardizer, there is a standardizer. Already we have defined this respective object, you know that one. We have already shown you the respective object declaration. So that is a standardizer object, which is the standard scalar class object. And then the second stage we are having here, that is our KNN. So KNN, here we have defined this KNN object under the K neighbors classifier. So two steps are there, two phases are there in this respective pipeline. The definition of pipeline class according to the scikit-learn is sequentially apply a list of transforms and a final estimator. And intermediate steps of pipeline must implement fit and transform methods, and the final estimator only needs to implement the fit. And now we are ready to create a pipeline, and here the object by providing with, here we can easily find that the list of steps, and here our steps are standard scalar and the respective KNN. And these steps are list of tuples consisting of name and the instance of the transformer or the respective estimator. So here we are having one tuple. You know the tuples will be enclosed within first brackets, and multiple items will be separated by commas. So here also we are having another tuple. So two steps, two phases are there in this pipeline. So one phase output will be the input of the next phase. So there should not be any leakage. And now also we are creating one search space. So create a space of candidate values. So here we are creating one dictionary, and this dictionary is having the key, that is a KNN __ n _ neighbors, and it is having the value which is nothing but one list. So this is our search space. So now whenever we are creating this pipe, that is a pipeline class object, so the respective outputs are coming. So it is showing that what are the different steps are there to be executed, and what are the different metrics, what are the default parameters it has got considered. Now we shall go for search over possible values for k. Create grid search. So there is a grid search CV implements a fit and a score method. So this grid search CV implements a fit and score method. It is very important. The parameters of the estimator used to apply these methods are optimized by cross validated grid search over a parameter grid. So now here we are going for the cross validated grid search over a parameter grid. So to have the better idea, let us go for this, how this classifier object has got defined under the grid search CV class. So here we are passing this pipeline object, we are passing this search underscore space, and this is our CV is equal to 5, that is a cross validation, 5-fold cross validation we are using, and verbose is equal to 0. So verbose is equal to 0 means no message will be printed, and we can have the different values for verbose. Will be showing that one dot fit x standard comma y. So in this way, we are for the different values whatever we have mentioned in the search space. So that is 1 to 10. This particular pipe, we are having the two stages in the pipe, two phases are there in the pipe. One is a scalar, and the other one, the one is the scalar, and the other one is the respective the KNN. So here for this particular scalar and the KNN, so two stages, two phases are there in the pipeline. So they will be executed, and cross validation value will be 5. So 5-fold validation, and in this way the x standard and y will be executed. The training will be done for different values mentioned in the search space. So combine pipeline and grid search CV to search over parameters for all processing steps at once. And fitting the grid search CV object not only searches for the best parameters but also automatically fits a new model on the whole training data set with the parameters that yielded the best cross validation performance. So if you execute this particular code, you see it is still executing. You can find that it is busy. So kernel is busy, that means it is still executing. So now you see there is no outcome we are getting because verbose is equal to 0. So if you go for 1, so minimum verbose will be there. It is telling that it is 50 fits. Why 50 fits? Why 50 fits? Because you know that here we are having 10 values for k, 10 values for k, and here we are having the 5-fold validation, so cross validation. So as a result of that, we are having the 50 fits here. 50 times the fits will be done for each and every value of k. We are having a 5-fold cross validation. So if you make this, if you want to get some more detailing, so make the verbose is equal to 2. So now we can find that we are getting the more detailing about this. So just consider the KNN underscore n underscore neighbors. When the value is 2, we are having the 5-fold cross validation. So 5 times we are getting this. For 3, 5 times. For 4, 1, 2, 3, 4, 5 times. For 5, 5 times. In this way, we shall proceed up to 10 here. So done 50 out of 50. Elapsed time is our 11 seconds. So here we are getting this one, but we are not getting the score. So if you go for the verbose is equal to 3, there we'll be getting the more detailing. Here we'll be getting the scores accordingly. You can find that here we are getting the scores. So depending upon the score whatever you are obtaining, so we'll be selecting the best one whatever is possible. So the best one whatever is possible you can get. So you see here we are having the 0.86, here we are having the 0.896, and then so many 6's are there, then 7. Here we are having the 0.93. so obviously I'm not going to go for this 5, but in case of 6 I'm finding this one, I think it is the maximum 0.96, and so many times 6 and then 7. So here we are having the 7, we are having this 8, we are having this 9, and so on 10. We are getting all this. So obviously we should take the optimum value for k. So how to get that one? In that case, we'll be just going for this clf.best estimator best underscore estimator underscore dot get underscore params method. So k underscore n underscore neighbors. So it is giving me the value 6. So in this way we can easily calculate that what should be the optimum value for the k for which my model will be more predictive, will have the best performance, and using this particular value of k will be going for our predictions, because using this particular grid search CV and also the pipeline, I think we have explained what is the purpose of grid search CV. Here we have passed the object of pipeline class. Here we have passed the search space, whatever you have mentioned here, the search space, and then we have passed the cross validation 5, and verbose is equal to, you can have the verbose value 0, 1, 2, 3, and so on. And dot fit, we are going for fitting, passing the x standard values and the y there. In this way we have shown you that how to calculate the optimum value for k in case of KNN classifier, so that my model performance will be best for that particular value for k. Thanks for watching this video.